Hello students, in this video I'm going to discuss chords of a circle. We are going to learn the theorem related to chords of a circle and also the converse theorem related to chords of a circle and their application, also proving riders using these theorems. First you need to understand what a chord is. A straight line segment. Remember, a chord is a straight line segment joining two points on a circle. What is a chord? It's a straight line joining two points on a circle. A straight line segment joining two points on a circle is a chord. Now, look at the picture below, the diagram, right? Can you see there are two chords, right? Now, this point and this point, right? These are the 2 points. And by joining these 2 points, if we draw a straight line, we call it a chord, right? It is a chord, right? So this is our chord. Do you remember the diameter, right? How do you draw the diameter? The diameter passes through the center of the circle, right? And again, it's a straight line segment, right? And it looks like this. This is our center, right? So if I draw a straight line that passes through the center, we call this a diameter, right? So is the diameter a chord? Of course. Remember, even the diameter is a chord, right? Why? The diameter is again a straight line by joining 2 points on the circle, right? So again, the diameter is a chord. And more importantly, remember, the diameter is the longest chord of a circle, right? This is the longest chord of a circle, right? So all these lines are chords. Particularly, the diameter is also a chord and it is the longest chord, right? The longest chord. Right, I'll explain this with some Sinhala also, right? Right, දැන් මේ පාඩමේ අපි mainly කතා කරන්නේ code එකක්, circle එකක code එකක් කියන්නේ මොකක්ද? ඒ වගේම මේ code එක සම්බන්ධයෙන් අපිට theorem එකක් තියෙනවා. ඒකේ converse theorem එකක් තියෙනවා. ඒ theorems දෙන්නව දැනගන්න ඕනේ. ඊට පස්සේ ඒ theorems use කරලා කරන්න පුළුවන් simple calculations මොනවද කියලා අපි දැනගන්න ඕනේ. ඒ වගේම පුතා ඔයා දැනගෙන ඉන්න ඕනේ මේ theorems use කරලා riders prove කරන්න. කියන්නේ තව දේවල් අපි prove කරන්න පුළුවන් වෙන්න ඕනේ මේ theorem එක base කරලා. theorems දෙන්නෙක් ඉගෙන ගන්නවා theorem එකයි converse theorem එකයි. Okay? right. එතකොට මුලින්ම ඔළුවට ගන්න ඕනේ දේ තමයි තේරුම් ගන්න ඕනේ දේ තමයි මොකද්ද code එකක් කියන්නේ. හරි code එකක් simply circle එකක points දෙන්නෙක් join කරලා අදින straight line එක. straight line segment එක. හරි? එතකොට අර circle එකේ points දෙන්නෙක් join වෙච්ච line එකක් මේක. right? එතකොට diameter එක කියන්නේ ඇත්තටම code එකක්. right? ඒකේ විශේෂත්වය තියෙන්නේ ඒ diameter එක කියන code එක circle එකේ එක හරහා තමයි යන්නේ. ඒ වගේම මෙයා තමයි longest code එක. හරි? අනිත් codes වලට වඩා මෙයාගේ length එක වැඩි. ඒකට මෙයා තමයි longest code එක. circle එකේ ඉන්න. Okay, now you know what a chord is. So let's take a look at the theorem related to chords of a circle. Right? There is a theorem that we should learn. Okay, now this is your theorem related to chords of a circle. Right, let's go through. The straight line joining the center of a circle to the midpoint of a chord is. Right? Right, now I'll erase these. Now look here, what you have here is a chord. The name of the chord is AB. And also you have the center of the circle and it is O. right? So O is center of the circle, AB is a chord, right? Then the straight line joining the center of a circle to the midpoint of a chord. Right, now we should mark the midpoint of this chord now, right? So let's call the midpoint as X, right? The middle of AB chord, and we call it X. Right, now what do we have? The center, the chord, and the middle point of the chord, which is X. Right, again, the straight line joining the center of a circle to the midpoint of a chord is perpendicular to the chord. So this means we need to draw a straight line by joining the center of the circle and the midpoint of AB chord. So let's draw it. So what happens? This straight line is perpendicular to the chord now. So that means we have a 90-degree angle over here and also on the opposite side. Right? So these two angles are 90 degrees. So that's our theorem. Right? The straight line joining the center of a circle to the midpoint of a chord is perpendicular to the chord. Okay, so OX is the straight line joining the center of a circle to the midpoint of the chord AP. Right, so according to the theorem, OX is perpendicular to AB. So you can use this symbol to denote that OX is perpendicular to AB, right? Right. Then again we can say these two angles, right? OXA, right? OXB are equal. So it's equal to 90 degrees. Okay, right. So this is your theorem. Right. Now let's do a simple calculation using this particular theorem. Right. Let's read the question. I took this question from 27.1 exercise from your textbook. It says PQ is a chord of a circle with center O. Right, this is our chord PQ, right? PQ chord. And this is our center. Right, then the midpoint of the chord is R. Right, here is our R. If PQ equals 12 centimeters and OR equals 8 centimeters, find the radius of the circle. So where is our radius now? Right, before that, let's mark these lengths, right? PQ length is 12 centimeters, right? Then they say OR equals, where is OR? OR, that's the perpendicular, right? It's the perpendicular. So it is 8 centimeters, this length. So they ask us to find the radius. Now, if I connect O and Q, isn't it the radius? This is our radius, right? This is the radius, right? So let's put R here, simple R. So we need to find the length of our radius. Right. Now, according to our theorem, we know that here we have 90 degrees, right? And this triangle is a right angle now, right? It's a right angle now. So when we see a right angle, we recall the Pythagoras theorem, right? So simply we can find the radius using the Pythagoras theorem, right? Now, this is our right angle, right? The hypotenuse is the radius now, right? So this length is 8 centimeters and this is 6 centimeters. How come? Why? We are given the length of PQ as 12 centimeters. And R is the midpoint means this length is, that means RQ length is half of 12 centimeters. And it should be 6 centimeters. Right, let's draw this right angle other way around. So by applying the Pythagoras theorem, we can easily find our radius. Right, now look at the steps that I have written. You can say, using the theorem, right, angle ORQ, right? It's this one, this angle, right? This is O, this is R, and this is Q, right? It is 90 degrees. So within brackets, you can mention because of this theorem, right? OR is perpendicular to PQ, and it's the theorem, right? So no need to say theorem here. You can just write this part, right? And then we can apply the Pythagoras theorem. So according to the Pythagoras theorem, R squared equals 6 squared plus 8 squared, right? Or 8 squared plus 6 squared, right? So 6 squared is 36, 8 squared is 64. When you add, you get 100. So it can be plus or minus, right? Square root 100. So what's the square root of 100? It should be 10, right? So always radius is a positive value. It's a length. So we can say radius equals 10 centimeters, right? So our radius is 10 centimeters. So this is a very simple calculation using the theorem, right? Right. Next, let's take a look at how we prove riders using the theorem. So proving riders is not that easy, right? So let's do it. Right. Riders prove කරන්න කලින් චුට්ටක් දැන් මේකත් සිංහල මික්ස් කරලා පොඩ්ඩක් පැහැදිලි කරන්න. දැන් මෙතනදී පුතා තේරුම් ගන්න ඕනේ අපි අර circle එක center එකේ ඉඳන් chord එකකට perpendicular line එකක් ඇඳුනහම හරි අපි දන්නවා එතන form වෙනවා 90 degrees angle එකක්. එතකොට මේ 90 degrees angle එකක් තියෙනකොට අපිට ඒක කියන්නේ triangle එකක් විදිහට ගත්තාම radius එකත් එක්ක එතන form වෙන triangle එක ඇවිල්ලා හරියටම right angle triangle එකක්. එතකොට right angle triangles එක්ක අපි දන්නවා relate වෙන theorem එක එකක් තමයි Pythagoras theorem එක. ඒකට මේ Pythagoras theorem එක apply කරලා අපිට සමහර වෙලාවට අපෙන් අහන දේවල් අපිට ටක් ගාලා හොයාගන්න පුළුවන් වෙනවා. Especially මේ විදිහට radius එක අහනකොට. Right. Now let's prove riders using the theorem. Right. Here I have taken fourth question from your textbook 27.2 exercise. PQ and QR are two chords of a circle, right? Where are these chords? PQ is over here and QR is here. With the center O, right? Center is here, O, which are perpendicular to each other. Now look here. These two chords are perpendicular to each other. The midpoint of PQ and QR are X and Y respectively. Now X is the midpoint of chord PQ. Y is the midpoint of chord QR. Show that OXQY is a rectangle. Right. Now they have joined the lines OX, right, and OY. So this figure should be a rectangle. So we should prove that this shape is a rectangle. Right. Now look here. This angle. What is this angle? OXQ. Right? It is exactly 90 degrees. Why? Because according to our theorem, right, OX is perpendicular to PQ, right? And similarly, this angle is also 90 degrees. What is this angle? OYQ. Angle OIQ equals 90 degrees. Again, the same reason. OX is perpendicular to QR, right? Because these are the straight lines joining the center of the circle to the midpoints of the chords, right? So this is the theorem, right? If you can, it's better if you can write the theorem. But I just wrote saying this line is perpendicular to that line, right? Okay. Now, we know already 3 angles inside this quadrilateral are 90 degrees. So, eventually, the other angle becomes 90 degrees. But where is the other angle? It's here, right? So, we can say XOY, right? XOY equals 360 degrees minus 90 degrees times 3. That is 270 degrees. So you get 90 degrees. Now, why did I write 360 degrees here? 360 degrees? Because the sum of the angles of a quadrilateral is 360 degrees. So this angle also 90 degrees. Now each angle of this quadrilateral is 90 degrees. All vertex angles are 90 degrees. So this can become even a square, right? But why this is not a square? Because it's given that this length, right? That is the length xq or qx is not equal to this length, qy, right? So these lengths are not equal means this is not a square, right? If you want, you can write this. Anyhow, these lengths are not equal. So we need to write like this, not saying opposite sides are equal. You can say length of xq is not equal to the length of qy. So you can say since all the angles in the quadrilateral, right, are equal to 90 degrees and the lengths are different, right? The lengths are different of this quadrilateral. So this is definitely a rectangle. Okay, next question, 5th question. AB and CD are 2 chords of a circle with center O. Right, here is our center. This is AB chord and here is our CD chord. The midpoints of AB and CD are P and Q. Okay, this is P, right, the midpoint of AB, and Q is the midpoint of CD. The chords AB and DC produced meet at M. Right, now when we produce the chord AB and chord CD, they meet at M. Show that angle POQ and angle PMQ are supplementary angles. Right, where are these 2 angles? Angle POQ, POQ, here, this one. PMQ, PMQ, here. So we should prove that these 2 angles are supplementary angles. So what are supplementary angles? When you add these 2 angles, you should get 180 degrees, right? So these are supplementary angles. Right, now, if you consider this quadrilateral, right? We know that the sum of the angles of a quadrilateral is 160 degrees. So we need to find Actually, we need to prove the addition of this angle and this angle should be 180 degrees. Now, what about these angles? What are they? They're actually right angles, right? It's 90 degrees each. Why? Because of our theorem, right? Can you see? Now, this OP is the perpendicular, right? OP is perpendicular to AB chord. So it should be 90 degrees here. And on the other side, OQ is perpendicular to chord CD, right? So here it should be 90 degrees, right? So this is how you write your steps. First, you need to say that this angle means OPM equals 90 degrees because OP is perpendicular to AB, right? This is based on our theorem. Then on the other hand, OQM, that means this 90 degrees angle, equals 90 degree because OQ, right? OQ is perpendicular to CD. Then when you consider the quadrilateral, OPMQ, right? OPMQ, when we add these angles, we should get 360 degrees. So that's what I have written, right? And the first two angles are these two angles, right? The next two angles are 90 degrees angles, right angles, right? So these two angles values are 90 degrees each. So when you add 90 plus 90, it will become 180, right? So when you transpose 180 to the other side, it will become a negative figure, right? So when you add these two angles, you will get 180 degrees. Therefore, you can say that these two angles are supplementary angles. Okay, let's read the next question. The midpoints of the chords AB and BC of the circle with center O are P and Q respectively. Show that POQ, angle POQ equals angle BAC plus ACB. Right. Now this is our chord AB and this is our chord BC. Here is our center, right? And these are the midpoints P and Q, right? Now where is this angle? POQ. POQ, it's here. Then the other two angles, BAC here and ACB, this one, right? So how do we prove this now? Now, using the theorem, we know that this angle is 90 degrees and this angle also 90 degrees. And when you consider this quadrilateral, right, two angles are 90 degrees each. This angle is actually POQ, right? And this angle is unknown, right? So when you consider this angle, right, it is common to the quadrilateral as well as this triangle, right? Okay, let's try to do this. Let's make two equations. Let's try to build up two equations, and by solving these two equations, let's prove this one, right? So when you apply the interior angle theorem to this triangle, you can form one equation, right? What is how you are going to write this? You have to say this angle plus this angle and this angle become 180 degrees, right? Okay, now these are the steps that you are going to write. First, you should say that these two angles are 90 degrees because of our theorem, right? So OPB, it's here, this angle, right? It's 90 degrees because OP is perpendicular to AB. Then OQB, this angle, 90 degrees one, equals 90 degrees because OQ is parallel to CD, right? Or it's better if you can write the theorem in words. The straight line joining likewise, right? Then, as I told you earlier, if you consider this pink color quadrilateral, right? Angle POQ, right? POQ means this angle, plus angle ABC. ABC angle is here, right? Plus these two 90 degrees angles equals 360 degrees. Why? Because sum of the angles of a quadrilateral is 360 degrees. So when you simplify, that means when you add 90 degrees and 90 degrees, it will become 180 degrees. And if you transpose this figure to the other side, it will become minus 180 degrees. So that means you get 180 degrees. So if you add these two angles, you get 180 degrees. So this is your first equation. Okay. Next, if you consider the triangle ABC, this angle plus this angle plus this angle becomes 180 degrees. Now, if you consider this angle, angle B, that means angle ABC, right? So this angle is common to this equation as well as the previous equation, right? So you have to write the step like this. You need to write the three angles and equals 180 degrees. Second equation, and you can write the reason also, sum of the angles of a triangle. Then when you equate the two equations, right, you can eliminate this common angle ABC by subtracting, right? So the remaining will be the answer, right? This one. Angle POQ equals angle BAC plus ACB. Right? So we got our answer. Right. Let's read the next question. PQ and RS are two equal chords of a circle with center O. Right. This is PQ chord, right? And this is RS chord. And they are equal in length. The midpoints of PQ and RS are X and Y respectively. Here is our X and here is our Y. So that this angle equals this angle. Now it says these two chords are equal chords. So this means these lengths are equal, right? Right. Now where are these angles? Angle XPS. XPS. It's here. The other angle is YSP. YSP is here. Right. So we should prove that these two angles are equal. Right. First of all, you can say that this angle and this angle are equal, and it is equal to 90 degrees. Right? Angle OXP is here, equals 90 degrees because OX is perpendicular to PQ. And then angle here, angle OYS equals 90 degrees because OY is perpendicular to SR, right? This is based on our theorem, right? So you can write the theorem even, right? And then it's given that PQ equals SR. So these are our chords, two chords. Right. Next, if you take half of each chord, again they are equal. Right? So PX means actually this length, half of PQ, right? Chord PQ. And SY is actually half of RS chord, right? So they are also equal, right? So for the reason I wrote X and Y are midpoints. And actually PQ and SR are equal, right? Then now using the congruence of triangles, actually we can arrive at our answer, right? So I'm going to consider these two triangles, right? What are the triangles that we are going to consider? Triangle PXO, right? PXO, here, this triangle, right? And then the triangle OSY, OSY, right? So if you consider these two triangles, we know definitely PX equals SY. Why? Because half of the equal chords are equal, definitely, right? Half of the equal chords are equal, right? Then what about these two sides of this these triangles? These are radii of the same circle, right? So OP equals OS because radii of the circle. So I have equal pair of sides, right? And then here also I have another equal pair of sides. And moreover, we know that these two angles are 90 degrees each. That means these two angles are equal. Angle OXP equals angle OYS, and it is 90 degrees. Now the radius is the hypotenuse of these two right angle triangles, right? So the hypotenuse is equal, right? And we have a right angle of these two triangles. Then also these two sides are equal. So according to RHS case, we can say that these two triangles are congruent, right? So when we have congruent triangles, the corresponding elements are equal, right? So if you consider this angle, that is actually XPO, right? XPO, and this angle, that is OSY, are equal because corresponding angles of congruent triangles or corresponding elements of congruent triangles. And I'm going to name it as 1, right? That's our first equation, right? Then when we consider triangle OPS, where is OPS? This middle triangle, this one, this blue color triangle, right? This angle and this angle. That means angle OPS and angle OSP are equal. Why? Because their opposite sides are equal. It is actually the radius of this circle. So since these two sides are equal, the opposite angles should be equal. So you can write this is actually isosceles triangle theorem, right? Angles opposite equal sides are equal. Right? We have two equal sides and their opposite angles are equal based on the isosceles triangle theorem. Right. Then when you add the first equation and the second equation, what do you get, right? If you add the left side of these two equations, that means if you add XPO and OPS, that means this red color angle and this black color angle, you get this full angle, which is XPS, right? So same way, when you add OSY and OSP, that means again red color angle and this black angle over here. You get the full angle, that means this angle YSP. So here is our answer. Right, now let's take a look at the converse theorem. Converse of the theorem that we learned. So according to the converse of the theorem, the perpendicular drawn from center of a circle to a chord bisects the chord. So this means if we draw a perpendicular line from the center of the circle to a chord, that perpendicular line will bisect the chord. That means the chord will be divided into two equal parts. Now this is our perpendicular line from center to the chord, right? So this is 90 degrees, this side also 90 degrees. So because of this perpendicular, our chord will be bisected. It will be divided into two equal parts. This length is equal to this length now. So that means let's say X is our midpoint of chord AB. So according to this theorem, AX equals XB. Okay. Right. Now using this theorem, let's do a simple calculation. I took this question from your textbook exercise 23.27.3. Right? First question. Right. According to this question, ABC is an equilateral triangle. If it is an equilateral triangle, that means all three sides are equal. Right? This is our triangle ABC. Right? And this is an equilateral triangle. Right. Then it says the vertices ABC lie on the circle with center O. Right. This is our center. These are the vertices. And vertices lie on the circle. The perpendicular drawn from O to BC is OX. Right. This is our perpendicular. Right. And then if XB equals 6 centimeters, right, let's mark it. XB, right, that means this length, right? If it is 6 centimeters, find the perimeter, right? The perimeter of the triangle ABC. Right. Now, how do we find the perimeter? Right, it's a very easy task, right? Now, if this length is 6 centimeters, according to the converse theorem, this length also should be 6 centimeters, right? Why? Because you can say XB, right? XB equals XC, right? So that means the length of CB or BC should be 12 centimeters. If XB is 6 centimeters, BC should be 6 times 2, 12 centimeters. Then the perimeter is, right? P means perimeter, right? It should be 12 times 3, right? Why 12 times 3? Because we have 3 sides and this is an equilateral triangle. So that means definitely we should multiply by 3 because all 3 sides are equal, right? So answer should be 36 centimeters. Okay, now let's move on to the difficult part. That means using this converse of the theorem, let's try to prove riders. Right, here I have taken the exercise 27.4 second question. Right? Right, let's read the question. The vertices ABC of the triangle ABC lie on the circle with center O. Right, these are the vertices of the triangle and they lie on the circle and the center is O. Next, the perpendiculars drawn from O to AB and BC are OX and OYs respectively. So these lines are perpendiculars. If AX equals CY, AX is this length, CY is this length. And they have given that these two lengths are equal. Right? Let's mark it. Prove that. Now we need to prove that ABC equals BCA. Right? Where is BAC? BAC, this angle. Right? And the other angle is BCA, this angle. So we should prove that these two angles are equal. Okay, let's do it. Right now, according to our theorem, the converse theorem, we know that this length should be equal to this length. Why? Because of this OX perpendicular, this AB chord is bisected, right? So similarly, this length should be equal to this length. Why? Because this OY perpendicular leads to bisect the BC chord, right? So all these lengths should be equal. Let's say if this is 5 centimeters, this should be 5 centimeters, and here also 5 centimeters, and this length also 5 centimeters, right? So first I wrote the given data, AX equals CY, right? This data. And then I multiplied both sides by 2, right? If I multiply AX by 2, I get 2AX, and CY by 2, I get 2CY. So what is 2AX? 2AX means it's exactly AB chord, right? Because these two lengths are equal now. So simply 2AX means it's AB. So similarly, 2CY means it's chord BC, right? This is actually because of our converse theorem. It's better if you can write the theorem in words, right? Not like this. You should write the converse theorem, these words, right? The theorem. Then if you consider the triangle ABC, right? This ABC triangle is an isosceles triangle. So you can easily say that these two angles are equal, right? So I wrote triangle ABC. Therefore, angle BAC equals angle BCA because of the isosceles triangle theorem. It is actually angles opposite equal sides are equal. So these are the two equal sides. Right, let's do the next question. AB and BC are two equal chords, right? AB is here and BC is here, and these two lengths are equal of a circle with center O. Here is our center, which are perpendicular to each other. Can you see? They are perpendicular to each other. And then we need to prove that OXBY is a square, right? Here is our OXBY square. Actually, we should call this as a quadrilateral now. Right, now it's given that AB equals BC. Two chords are equal. Then since OX is perpendicular to AB, these two lengths are equal, right? And since OX is perpendicular to BC, these two lengths should be equal. And also, since AB equals BC, all these lengths are equal, right? So using the converse theorem, we can write AY equals YB, BX equals, sorry, it should be XC. So as I told you, all these lengths are equal, right? Therefore, you can easily say the two sides inside this quadrilateral, that is BY or YB and XB or BX, right? These two sides are actually equal in length. YB equals BX. Right. Now, do you remember? This is one of the special properties of a square. If two adjacent sides are equal, it has to be a square, right? And also notice, this angle also should be 90 degrees. Why? Because it's given that all these three angles are 90 degrees. So if this is a quadrilateral, sum of the angles of a quadrilateral is 360 degrees. So when you deduct 3 times of 90 degrees from 360 degrees, you get 90 degrees over here. So all the vertex angles are 90 degrees. And especially since two adjacent sides are equal in length, we can say that this is a square. Okay, this is a square. AB and AC are two chords of a circle with center O, right? So this is AB and here is AC. Perpendicular drawn from O to AC is OQ, right? This is OQ, the perpendicular. 2AB equals AC. If 2AB equals AC, prove that AB equals AQ. AC can AB wage twice. There is AB here and AQ here. So we should prove that these two lengths are equal. Now, according to the converse theorem, we can say that AC equals QC, right? Because OQ is the perpendicular. So since the perpendicular, this side is equal to this side, right? So we can say AQ equals QC. Right. Now, what about when we take twice of AQ? 2 times of AQ, right? It should be AC, right? AQ වගේ දෙගුණයක් කියන්නේ තනිකරම full AC length එකනේ. Right? So we can write 2AQ equals AC. And it's our first equation. Right? And also it's given that, right, as a data, 2AB, this part, 2AB equals AC. So that's my second equation. Right? Right. Now, can you see? Here we have AC and here also we have AC. So that means 2AQ equals 2AB. So when we cancel 2, right, by dividing, the remaining will be AQ equals AB. So that means AB equals 18. Okay, right. Now let's do the questions in the miscellaneous exercise. First question, a chord of a circle lies 8 centimeters from the center. Right, now this is our center and let's call it O. So the distance between the center to the chord is 8 centimeters, right? And this should be the perpendicular distance, right? The perpendicular. If the length of the chord is 12 centimeters, right? Let's call this chord as AB, right? So the length of this chord is 12 centimeters. Find the radius of the circle. Right, now radius is this, right? So let's put R. Right, so it's an easy question. We did a similar question before, right? For us to find the radius, we can consider this particular triangle. This is a right angle triangle. So we can apply which theorem? Pythagorean or Pythagoras theorem, right? So it's given that AB equals 12 centimeters. And let's call the midpoint as X, right? So that means this is not AX, this should be XB, right? XB is half of 12, right? Because of which theorem? The converse theorem, okay? So it is 6 centimeters. Half of 12 is 6 centimeters. So when you consider the right angle triangle, the radius becomes the hypotenuse, right? And here this side is 8 centimeters and this side is 6 centimeters. So R squared equals 8 squared plus 6 squared. You get 64 plus 36, that is 100. So R should be the square root plus or minus square root of 100. And radius is a positive value. So we can say radius equals 10 centimeters. So it's an easy question. Okay, next question. Radius of a circle with center O is 5 centimeters. Lengths of chords AB, BC, AB and BC are 6 centimeters and 8 centimeters respectively. This is chord AB. The length of this chord is 6 centimeters. And here is our chord BC. And the length of this chord is 8 centimeters. The midpoints of the chords are X and Y respectively. Right, here is X and here is Y. Find the perimeter of the quadrilateral OXPY, the perimeter. The length of AB chord is 6 centimeters, right? The length of chord AB is 6 centimeters, right? Now, where is our quadrilateral? It's here, right? So when we consider the length of BX, right? That is this length. The length of BX, it should be half of 6 centimeters, right? Because X is the midpoint of chord AB, right? The length of chord AB is 6 centimeters. Then half of this chord should be half of 6, that is 3 centimeters, right? So the length of BX is 3 centimeters. Similarly, the length of BC is 8 centimeters. So this BY, right? The length of BY in our quadrilateral, right? Here, this length should be half of 8 centimeters, which is 4 centimeters. If you consider this angle, this should be 90 degrees. Why? Because of our theorem. because we see there's a straight line joining the midpoint of a chord and the center of the circle. So definitely this should be 90 degrees angle. And also this angle should be 90 degrees. Right? Why? Again, the same theory. This is the theory related to chords of circles. Chords of a circle. So what is this quadrilateral? This is actually a rectangle. This is a rectangle. Right? Because vertex angles are 90 degrees each. Right? Then we can find the perimeter of this rectangle. Hope you remember the way we find the perimeter of a rectangle. You need to add the length and the breadth and then multiply by 2, right? So it should be 14 centimeters. Or you can write 3 plus 3, right? Because this length is 4 centimeters and this length should be 4 centimeters. And here this length is 3 centimeters and here also 3 centimeters. So 3 plus 3 plus 4 plus 4. Like this. Or you can write like this. So the perimeter is 14 centimeters. Okay, let's read the next question. The length of the chord AB of the circle with center O is 8 centimeters. Now here is our chord AB, right? The length of this chord is 8 centimeters. The perpendicular drawn from O to the chord intersects the chord at X. The perpendicular is this, right? And X should be actually here, right? X is this point and meets the circle at Y, right? This is Y. It meets the circle at Y. It meets the circle at Y, right? Then if XY equals 3 centimeters, so this length is 3 centimeters. Find the radius of the circle. Right, now we know that this length of AX is 4 centimeters because AB is 8 centimeters. So AX becomes half of 8 centimeters, which is 4 centimeters. Then where is our radius? If I draw this line, this should be radius, right? So let's denote radius using R. Right. Now, if you take this length, what is this? This is again the radius. Now, we know that this length is 3 centimeters. Then what about the length of OX? It should be R minus 3 centimeters, right? Okay, now you see there is a right angle triangle. Triangle OAX. So you can apply Pythagoras theorem and find the radius now, right? It should be R squared equals 4 squared, right? Plus R minus 3 squared. Right, now how do you expand this? Do you remember? First, you have to take the square of R, that is R squared, right? As the last term, you have to take the square of minus 3. That is minus 3 times minus 3 plus 9. Then you should multiply these two terms and again multiply by 2. R times minus 3 times 2. R times minus 3 is minus 3R times 2 means minus 6R. right? So it should be minus 6r. Right. Now 4 squared is 16, right? Then you can cancel r squared. Let's transpose minus 6r to the other side and it will become plus 6r. And when you add 16 and 9, you get 25. So 6r equals 25. So r should be 25 divided by 6 and you will get 4 and 1/6 centimeters for your radius. Okay, let's read the next question. AB is a chord of a circle with center O. Right, this is our chord. The midpoint of chord is X. Here is our X. The point C lies on the line drawn from X to point O. Right, here is our C. Prove that AC equals BC. So AC is here and BC is here. So to prove this, we can use congruence of triangles, right? Now, if you consider the triangle CXA, right? This triangle CAX, right? And the triangle CBX, the other triangle over here, right? AX is equal to XB and it's given, right? It says that the midpoint of X, the midpoint is X, right? So, and it's given that these two sides are equal, right? And also, if you consider this angle over here, it should be 90 degrees. The other angle also 90 degrees because of our theorem, the theorem related to chords of circle, chords of a circle. So you can say CAX, angle CXA, this angle, and angle CXB, this angle equals 90 degrees, and it is because of the theorem. So you need to write the theorem, right? I didn't write it fully. This is because of a theorem. Then if you consider this side, and we can see that it is common to both triangles. So CX equals CX and it's the common side. Right, so we have two pairs of sides and one pair of angles. So these two triangles are congruent based on SAS case, and this angle is an included angle, right? And then easily we can say AC equals BC because these two are corresponding sides of these two congruent triangles. So because of corresponding elements of congruent triangles, we can say that AC equals BC. Okay, let's read the next question. Fifth question. PQ, PR are two chords of a circle with center O. This is PQ. And here is our PR. The perpendiculars drawn from O to PQ and PR are OX and OY. Right, these are the two perpendiculars. If XR and QI are straight lines, right? XR is here, right? And QY is here. And these are straight lines. Prove that PQ equals PR. Right, now when you consider this triangle and this triangle, that means triangle OXQ and triangle OYR. We know that this angle and this angle are 90 degrees because OX and OY are perpendiculars, right? So we can write that OXQ, this angle, OIR, this angle, are equal to 90 degrees because of our theorem related to chords of a circle. So you need to write the theorem. I didn't write it fully. And then we see that these two angles are equal, right? These two angles are equal because they are vertically opposite angles. So these angles are XOQ and on the other side YOR. Okay? Right. Then if you consider this line and this line, what are these? These are radii of the circle. So obviously these two are equal. So you can say OQ equals OR. The reason is radii. Radii of the same circle, right? Then, yes, we can see that there are two pairs of angles and one pair of side. So under the case AAS, angle, side, these two triangles are congruent, right? If these two triangles are congruent, we can say that this side, right, and this side are equal because they are corresponding elements, corresponding sides of the congruent triangles. So XQ, right, this side, and YR, this side, are equal. Then what I did was I multiplied both sides by 2. So I get 2XQ equals 2YR. Now when you consider 2XQ, what is 2XQ? It is exactly PQ, right? Because according to our theorem, this side and this side should be equal, right? Same with the other side. 2YR is PR, right? This chord. And we know that these two sides are equal. That's why we say 2YR equals PR. Right? So both chords are equal. Right. Now let's read the next question. A chord of length 24 centimeters lies 5 centimeters away from the center of a circle. Another chord lies 12 centimeters from the center. And then we need to find its length. Right, let's draw a diagram now. Right, now here is our center O. Right, this pink color chord is the chord lies 5 centimeters away from the center. So I'll mark here 5 centimeters. Right, and what's the length of this chord? 24 centimeters. That means this side 12 centimeters and other side is 12 centimeters. Right? Right. Now the other chord is here, right? It is away from 12 centimeters. So I'll mark 12 centimeters here. Okay, now we need to find its length. So we need to find the length of this chord. Right. Notice this. Now, if you consider the lengths of two chords, the chord which is more closer to the center has a higher length than the chord which is more away from the center. Okay? මේක notice කරාද දැන් center එකට කිට්ටු වෙන්න තමයි chord එකේ length එක වැඩි වෙන්නේ. ඒතර center එකෙන් දුරට යනකොට code එකේ දිග නැත්නම් length එක එන්න අඩු වෙනවා. Right, now for us to find the length of this chord, we need to find the radius of this circle. Right, now if I mark the radius in this diagram, it should be like this, right? This is our radius. Okay, now we need to name these sides, these lengths. Okay, first we need to label, name these chords. Let's say this is AB chord, and here we have CD chord, right? And the midpoints are P and Q, right? P and Q. For us to find the length of CD, first we need to find the radius of this circle. So first I'm going to apply the Pythagoras theorem to this particular right angle triangle and find the radius, right? So we can write triangle OPB. R squared equals 5 squared plus 12 squared, right? This side is 5 centimeters and this side is 12 centimeters. So 5 squared means 25, 12 squared means 144. And R squared should be equal to 169. Now don't find the value of R, right? Let's straight away, you will get to know why I did not find the radius, right? R squared is 169, right? Then I apply again the Pythagoras theorem to the other right angle triangle, that is OQD, this right angle triangle, right? So here R squared equals 12 squared, right? Plus QD, this side, right? QD squared, right? Now what is, so how do we find QD squared? By deducting 12 squared from R squared. So R squared is now 169. So that's why I didn't find the value of R, because in this question we are not supposed to find the radius. We need to find a length. For the ease of the calculation, I just, kept it without solving the value of R, right? So from 169, deduct 12 squared, that means 144. So we get 25. So QD should be plus or minus square root of 25, which is 5 centimeters. A length is a positive value. And if QD is 5 centimeters, now where is QD? Here. Now we know this side and this side are, these two lengths are equal, right? So that means CD is twice of QD, right? So when we multiply 5 by 2, we get the length of CD. So it should be 5 times 2, 10 centimeters. The length of CD is 10 centimeters. Okay, let's read the next question. The vertices ABC of equilateral triangle ABC lie on the circle with center O. Right, this is our equilateral triangle. The perpendiculars drawn from O to AB, AC, BC are OX, OY and OZ. Right, here are the perpendiculars. Right. Prove that OX equals OY equals OZ. Now, when you consider the perpendicular OX, right? Because of OX, this length and this length should be equal based on our converse theorem. So similarly, because of OI, this side and this side should be equal. And also these two sides, these two lengths are equal. Right now, all these lengths are also equal. So here I'm going to do a construction, right? So let's draw a line like this. Right now you can see two triangles, right? There are two triangles. So if we try to prove the congruence of these two triangles like this, let's see. In triangle OZC, right? It is this one, this triangle. And the triangle OYC, right? The other one. Now we know that this angle and this angle are 90 degrees because of our theorem, the theorem related to chords of circle. So you need to write the theorem here, right? And then we can say that this side, that is CZ, right? And this side, CY are equal. That is because this is an equilateral triangle. So all these lengths are equal, right? And then you can see that there is a common side, and it is actually our radius, right? This is our radius. You can write radius here or the common side. So let's write the common side here. The common side is the radius, common side, right? And therefore, based on RHS, these two triangles are congruent. So this means corresponding elements should be equal, right? So I wrote this OY and OZ, they are equal, right? OZ equals OY, and it is my first equation. So in the same manner, we are going to do a construction here, and no need to write all the steps. You can say similarly, these two triangles are congruent. Again, for same reasons, it is based on RHS, right? Right. Therefore, the corresponding elements are equal. These are actually corresponding sides. So what are these two sides? This OX and OZ, right? So you can write OZ equals OY, and it is the second equation. So if you equate two equations, you can arrive at your answer. OX equals OY equals OZ. Right, this is the last question in the miscellaneous exercise. Question number 8. P, Q, and RS are two chords of a circle with center O. Right, here is our PQ chord, and this is our RS chord. The perpendiculars drawn from O to PQ and RS are OX and OY. These are the perpendiculars. Show that this equation, right? So how do you prove this? Now, when you see the square terms, right, what can you recall? Do you recall the Pythagoras theorem? Of course. We can apply Pythagoras theorem and try to achieve our answer, right? Okay. Now, for this, we need to do a little construction, right? So I'm going to draw a line like this. Because for us to apply Pythagoras theorem, we have to have triangles, right? So here I'm drawing these two dashed lines to get two triangles. Okay, now let's apply the Pythagoras theorem to these two triangles. Right, first let's consider the triangle XOQ. XOQ triangle, this triangle. Right, now when we apply Pythagoras theorem, now what is this side? What is this side? It is our radius, right? So let's call it R. Even here is our radius, right? So we can write R squared equals, what are the other two sides? OX, that is our perpendicular, right? OX squared. And then the other side is XQ, right? XQ squared. Right. Now, if you look at the equation that you have to prove, do you have the term XQ? There is no term XQ here, right? But you have this term PQ. Now, is there a relationship between XQ and PQ? Of course. Now, because of the theorem, actually the converse theorem, these two sides should be equal. These two lengths should be equal. So actually Px equals Xq. Or in other words, PQ is twice of XQ. So what about XQ? What is XQ then? It's exactly half of PQ. So I can say that XQ equals PQ, half of PQ, right? So what I do is, instead of writing XQ squared, I write PQ over 2 squared, this term, right? Now when you square it will become PQ squared, and what is the square value of 2? It's 4. Right, now what you have is R squared equals OX squared plus PQ squared over 4. Now let's get rid of this 4, right? For this, we need to multiply each term of this equation by 4, right? So when you multiply each term by 4, what do you get? R squared times 4, 4R squared, then 4x squared. And when you multiply this term by 4, the 4 will be cancelled. 2 4s will be cancelled and you get PQ squared. So let's name it as equation 1. Right, then let's apply the theorem to the Pythagoras theorem to the other right angle triangle. Right, so it is triangle OYS. Right, R squared equals this side OY squared and this side SY squared. Right, then R squared equals OY squared. Now instead of SY, what can I write? Now this SY is not in this equation, but we have RS. So there is a relationship between SY and RS. SY means exactly half of the whole chord, that is RS. So I write, instead of SY, I can write RS over 2 squared. So when you square it, you get RS squared 4, right? When you get rid of 4, for you to get rid of 4, you have to multiply each term by 4. So you get 4R squared, 4OI squared, and RS squared. Right, now this is your second equation. Now, let's equate these two equations and try to arrive at our answer, right? So let's equate two equations. 1 equals 2, right? What is 1? The first equation. Now we see that these two terms are equal. So that means we can write these two terms on the left side, right? But here what I do is, since in our answer we have PQ squared first. First we have PQ squared. So what I do is I write PQ squared first and then plus OX squared. මේ දෙන්න මාරු කරලා ලියන්නේ. හරි? මොකද answer එකේ තියෙන්නේ මුලින්ම PQ squared නේ. ඒ නිසා. Right. Then what is it? The other side, that means these two terms, right? So it should be 4y squared plus RS squared. Right, now what I do is, since RS squared is on the left side, I'm going to transpose this term to the left side. So it will become minus RS squared. Then this term plus 4OX squared, I'm going to transfer to the right side. So it will become minus OX squared. Now we have arrived at our answer. This is our answer, right? We got the exact answer. Okay, then hope you understood about the theorem and the converse theorem related to chords of circles and their applications and proving riders using these theorems. Okay, then see you in another video. Don't forget to subscribe.